Everyone. Thank you for being here and excited to go over the 6-month weather outlook with you today, specifically focused on the Asia Pacific region. So, a quick intro to me. My name is Dr. Hansi Singh. I am CEO and founder of Planet AI. I'm a scientist. Our company, Planet AI, is a science-based company fundamentally. I have worked as a fellow at the U.S. Department of Energy, a research fellow. I've also worked as a professor, so in academia. I still contribute to science-based advances in Earth system modeling, but my primary aim for starting this company was that we could bring state-of-the-art intelligence from the research world to the real world to help folks make decisions. And this is a great time because there is a lot of very predictable weather on the horizon over the next 6 months. So I'm excited to tell you all about it. So this is our roadmap of what we'll be talking about. So the big story for the Asia Pacific is the Super El Niño that is on the way. So impacts over APAC will be quite significant. We'll go over some of these weather phenomena and their potential impacts. And then we will also actually take a little bit of a look into Q1 2027. So the thing is that when you have a large event like an El Nino, specifically an extremely strong record-breaking El Nino, what we expect is that, it will strengthen and then we'll actually see it wane quite quickly in the new year. So we will talk about that as well. So really excited to dig right in. Before we get started, I do want to say something about long-range weather forecasting, just to make sure that, we're all on the same page about the science behind this work. So when we want to predict something within, say, a 14-day time horizon, we use weather forecasting models, which are primarily models of the atmosphere. They're very complex models, usually tens of thousands of lines of code, and they include many different components of the atmosphere, including chemistry, radiation, convection, etc. In order to predict anything beyond 30 or 14 days, we really need an Earth system model. The reason for this is because the atmosphere does not really have much initial condition predictability beyond 14 days. On the other hand, the ocean has centuries of memory. Ice has decades of memory. Land surfaces have years of memory. All of these help contribute to lengthening the time horizon over which we can make really skillful predictions. Note that we cannot tell you day-to-day predictions, but we can tell you week to week, month to month predictions going out several months into the future, which is what we're going to do. We're going to go over the next 6 months today. So the big story right now is that El Nino is here. El Nino is here and it is strengthening. So El Nino will be the major global driver of anomalous weather patterns over the Asia Pacific over the next 6 months. And so this is what I'm going to be talking about primarily today. So before we get started on that, I do need to provide a little bit of intro about what is El Nino. So Earth scientists call El Nino a mode of interannual variability. It is essentially a fluctuation in the Earth system that occurs over a period of about 3 to 7 years, particularly. This fluctuation is enormous. So the Pacific Ocean, the Pacific Ocean is enormous. It's about half of our planet. And the El Nino signal is this huge swath of warmer than usual waters, anomalously warm waters that extends about 3/4 of the way across this ocean basin. And the reason why this matters and why this doesn't necessarily stay in the tropical Pacific is teleconnections. So our Earth system is teleconnected. This means that various types of atmospheric and oceanic wave activity propagate the signal from this El Nino all over the planet impacting weather. So this is why this event is so significant because we can predict it really well over, the next 6 months, the next year. And we know that it has many impacts. And so because of that, we can predict those impacts as well. And those weather impacts are extremely well studied, which is great because that means that we have a real large window right now for being able to understand what is going to happen over the next 6 months and to be able to take whatever measures we need to take. So this particular El Nino event that is going to be happening is record breaking. So let's look at the forecast. So this is the forecast through January 2027. We have the ECMWF forecast shown on here too in red. Our forecast is in purple, with the light purple being kind of the confidence interval. And you see that we are, by December, we will be above 3 degrees anomaly over the Nino 3.4 region. So we're forecasting about a 3.6 plus or minus 0.2 degrees Celsius. We're a little bit less extreme than the ECMWF, which is forecasting a 3.9 degree anomaly, almost 4. And the NOAA model actually does forecast a 4. So, I mean, this is huge. And let me just put this in context of previous El Nino events. So this is a time series of El Nino events since 1982. And what you can see, these El Nino events are these like kind of big peaks that show up. El Nino is very dramatic because unlike La Ninas, which kind of tend to be sort of longer and softer, El Ninos are just these like big mountains that show up in the time series of the tropical Pacific temperatures. And so, you see these many El Ninos, and this is the forecast, our forecast for the strength of this El Nino. So you can see nobody ever hits that number ever. In fact, the Nino 3.4 index has never been above 3.0. So this is pretty record breaking and pretty remarkable. So yeah, this is definitely one for the record books so far. Keep in mind, right, we only have records until 1982. There were some very strong El Nino events in the past. It's just that nobody was recording temperatures over the tropical Pacific, so we don't really know how strong those are. But we can say that over, the last 45 years or so, we have never seen the tropical Pacific getting to such extreme temperatures as we expect for this particular event. Now, what are the major impacts of this El Nino over APAC? So one thing about El Nino that's really important to remember is that it's this huge blush of heat over the tropical Pacific. And so because of this heat over the tropical Pacific, which is being released from the ocean to the atmosphere, this is on the order of 10 to the 20 joules. It's just an enormous amount of heat. Um, this heat is going to reorganize the global atmospheric circulation. And APAC is literally like, kind of right in the crosshairs, along with South America and Central America. Like these are the regions that are just the most impacted by El Nino events. So, why is APAC so impacted? So let's take a look at sort of the circulation patterns in this region. So here is a map, and here is a tropical circulation known as the Walker circulation. So the Walker circulation essentially has it's basically like an east-west circulation. It has a region of high rainfall over the West Pacific. So this is why so much of the West Pacific is so rainy, because you have this lovely, area of, very wet air converging, rising, creating these giant towers of cumulonimbus, and which are, just really thick thunderclouds, and then creating a ton of rain. I mean, this is just such a rainy region. And to a smaller extent, you have the same kind of situation over South America as well. Now, this is normally how the circulation looks like, but El Nino, with that huge amount of heat that is exiting from the ocean to the atmosphere in the East Pacific Ocean, it just totally changes where this convection, this storminess happens. So instead of the storminess happening over the West Pacific, the storminess now with El Nino is going to happen in the Central Pacific. The Central Pacific, a little bit in the East Pacific. And so what that means is that now, instead of a bunch of storm activity going on over the West Pacific, it's instead going to be a very dry region. We're going to have what we call subsidence, which is just like sinking air that's hot. And yeah, no huge cumulus towers, no deep convection, not in the same way that we usually have it. So this is called a major shift in the Walker circulation and just this abundant rainfall that huge areas of APAC are used to having is just going to completely sort of shut down with this major El Nino event. The other really interesting thing about this El Nino that is important is that with El Nino, we have this nice mode of variability called the MJO, and El Nino suppresses the MJO. Here, what we're seeing is different phases of the MJO. So what the MJO does is essentially like distributes precipitation across the Indian and the Pacific Basin, Pacific Oceans and the tropics over a period of like 30 to 60 days or so. And so what that means is that like everybody gets rain, you know? So for a while it'll rain over, East Africa, then it moves to like, the Indian subcontinent and Southeast Asia, then it sits over Oceania, Australia, specifically West Australia gets a lot of rain, and then it moves over the tropical Pacific, but then here, you see this kind of resonance going on over South America. It is just like a very good way of like distributing rainfall. And El Nino essentially just puts a sucker punch to this thing. It just stops it. And so what that means is that this nice kind of distribution of rainfall that happens over these very regular cycles is just going to not happen. And so it means that regions in Asia in particular are going to be subject to drought. So the major impact, as I've said now, for Asia, the Asia Pacific, the story here is going to be drought. So this means that impacts over South Asia or over Asia, APAC in particular, will be because of less water. So in particular, we see less hydropower, less water availability for agriculture. If there's river transport, we will see limitations to that. And we will see just less water available for heavy industry, including mining. With this reduced water and often increased temperatures, we will see more summer energy grid demand over many regions. We will also see wildfires. And then over some regions, as this kind of El Nino dissipates into 2027, we will actually see flooding and landslides. And they could be, pretty significant because regions will have had, 6 months to dry out excessively. So this is a little bit of a overview of temperatures over APAC, specifically temperature anomalies. And you can see that generally speaking, this region is going to be warmer than usual with the coming Super El Nino. So this is kind of a very kind of characteristic impact of a El Nino, which is just that you're releasing so much heat from the ocean to the atmosphere. And so we see warming over many parts of the globe. This El Nino in particular will also change where tropical cyclone activity happens. So, and it is a bit seasonal. So it's important to kind of remember that the impacts are not just something that you can, just list off really quickly, that you really have to look at it from a more seasonal perspective. So this upper figure, it shows cyclone tracks in June, July, August. Red means more tracks during an El Nino year, and blue means less tracks. And so what you can see is that over the summer months, we really do expect more cyclone tracks, very particularly over the Philippines, Taiwan, near the Hong Kong region in Southeast China. All of these regions will receive or will be likely to get more tropical cyclone activity. In September, October, and November, on the other hand, as El Nino is just going to be getting stronger and stronger, we actually will see a lot of these cyclones that form over the Pacific kind of tracking away from this region. This doesn't mean that we're not going to get any cyclones in this region, but it is just less likely than it is during an La Nina year. So, this is kind of an interesting story, and it is a story that varies by region and varies by time of year. So, important to just kind of keep in mind that the impacts on typhoon activity are kind of subtle. And so, it's important to remember these different sort of modes at different times of year. A major impact of El Nino, we've talked about it in terms of drying, is that the South Asian summer monsoon will be shorter and weaker. We see this very strongly within the context of our forecasts, and this is, yeah, expected. It's very, very robust impact of El Nino over South Asia. So, what does this mean? Well, first of all, the monsoon is what usually cools this region. And so, yeah, this region is just going to stay really hot and really dry into the fall. The other thing to remember is that this is a region where there's a lot of subsistence agriculture, so that is not going to be great. Generally, there will be less water resources for ag. There will be issues with hydropower. Mining operations that require significant water resources will be impacted, as will be manufacturing and heavy industry. Speaking of limitations of water, and specifically impacts on industry, Taiwan, as we know, is a major semiconductor manufacturer. And what we see is major drying over this island over through November 2026. So it is very likely that this region is going to be in a seasonal drought. And so, will this impact semiconductor manufacturing? Not sure. It really is going to depend specifically on what their water resource situation looks like right now. This region has gone through droughts before, and at those times we have seen impacts on manufacturing. So it really just kind of depends on what the baseline situation is for them going into the next few months, which will be very dry. In general, Southeast Asia and Oceania will be much drier than usual. This is a very known, well-known impact of El Nino, and we expect it over this region through the end of the year or to the end of the year. And we expect that it's going to have impacts on industries within this area, specifically commercial agriculture. Palms, for example, love water. So if you have less water, they do not grow as well. Rice is also extremely water hungry. We also expect to see impacts on subsistence agriculture, as well as impacts on mining, heavy industries, and any river transportation that's occurring in this region. This is not an area where necessarily there's transportation of items by heavy industry occurs through rails. It tends to occur through rivers. And so this is an area that could be a potential bottleneck. Australia is also expected to be significantly drier than usual as El Nino grows and peaks. And so we can expect some impacts, particularly on East Australia, for commercial agriculture, for mining, and for heavy industry in particular. And for these two regions, particularly Southeast Asia, Oceania, and Australia, a big danger here is that prolonged drier than usual conditions can increase the amount of flammable fuels, in other words, dry vegetation, and the risk of major wildfires goes up. And particularly for the this region right here, Southeast Asia and Oceania, often what we tend to see is that fires that are started for agricultural purposes, they very easily can get out of hand. And so this is where major wildfire events can get started. And then, of course, with Australia, we've seen some, years where we just have a ridiculous amount of wildfire activity. So this is definitely a danger until this El Nino goes into its waning phase in 2027. I wanted to take a quick look at the winds and the solar radiation over the Asia Pacific as well. The reason why I want to do this is because I know this probably feels like a bit of a gloom and doom kind of talk, and I don't want it to be that way because actually renewable energy resources look like they can be quite favorable for this region over the next 6 months. So the blue colors here indicate higher than usual winds. And so we can see large areas have abundant wind resources. Note that here you can actually see certain kinds of cyclone tracks showing up in our forecast. So that's what these dark regions are. But just in general, this area is going to be windier than usual over the next, to the end of 2026. We see a similar story when it comes to solar resources. So the orange colors indicate higher than usual solar resources. So yeah, this is a good time to have wind turbines and solar panels over this region. Now, what do we expect in 2027? So, there's just all of this excitement about this El Nino, major impacts on the water cycle, on temperatures, as well as on energy stack generation, particularly for renewables. But in the new year, this El Nino will peak and begin to dissipate. So we expect this peak to be like I would put it at December. Some El Ninos have, peaked in November, but our model suggests that the peak is going to be in December, which is similar to what we see with the ECMWF model. NOAA has it peaking in November. That's a little bit more unusual, though not unheard of. So, we'll see how this plays out. But note that, this is a amalgamation, a collection of many different El Nino events. And what you can see is that as we go to the end of the year, the El Nino, grows and grows and grows. And then as soon as we hit this December, right, we see this very rapid decline. So usually sometime by mid-spring, like we will be back in neutral conditions. So it's almost like, wow, look at this train that just hit us, right? I mean, it's just like, wham bam, and where did it go? And so this kind of waning signal of the El Nino is also expected to be significant. So one area that we really see kind of a strong kind of indication that the waning of the El Nino is going to really result in some interesting weather is looking over Southeast China and the Koreas and Japan and Taiwan. So very particularly, we see that at the start of 2027, we can likely expect a lot of rainfall to resume over this region. We also see some evidence that rainfall will be starting to recover in Indonesia and other parts of Southeast Asia. And just, keep in mind, it's great to have rainfall, but sometimes if there is a prolonged dry period and that is followed by a ton of rain, it can be hazardous, right? So flooding, landslides, etc. So just something to keep in mind that, this is likely going to be on the way as we get into the waning phase of the El Nino in 2027. So, to conclude, I just want to say there's just so much scientific research on El Nino and its weather impacts and its huge weather impacts across the Asia Pacific. And so, these are rainfall, renewable energy availability, impacts on tropical cyclones. Yeah, so much literature, so much knowledge. And so I think, the bottom line is really that there's a very massive but predictable weather phenomenon that is on the way. It's going to be record breaking, but the great opportunity here is just how predictable it is. And so this is just a great opportunity to like build resilience in your operations, your portfolio, because like we know what's coming. And it is something that we don't need to feel caught us off guard. Like it's coming and we can prepare for it. We can do our very best to prepare for it. So thank you so much for being here. And, a couple of just kind of quick announcements. Our next webinar is going to be on wildfires. El Nino increases the risk of wildfires around the planet. So it really is a good time to be talking about wildfire risks and what we're seeing in the forecasts. And if you miss us during the times that you don't see us, you can always catch us on YouTube. Specifically, you can watch our growing collection of previous webinars, a lot of which has information on the science of the Earth system and long-range predictions.